Welcome back. We're going to look at our first class of organic compounds called alcohols. Now, as we saw in the previous video on functional groups, alcohols have a functional group called the hydroxyl group bonded to a chain of carbons. So to identify an alcohol, we need to just look for this hydroxyl group coming off of a chain of carbons. So let's go through some examples of naming and drawing alcohols, and that'll be it for this video. I won't get into any of the properties of alcohols. For this time, just know that alcohols are chemically reactive. That hydroxyl group confers some reactivity to it because this oxygen now has two lone pairs of electrons. It's very electronegative, so that sticks out like a sore thumb and is a little bit like a beacon to other molecules that might want to do business with it. So having that hydroxyl group there confers some chemical properties to it, some extra behavior that the alcohol is willing to partake in. So there's the generic functional group, the hydroxyl group for alcohols. Now, how do we name them? Well, similar to how we name alkanes, except with just a minor change. The suffix will change in this case, and how we number the alcohol will also change because now I've got this hydroxyl group that takes precedence. So let's look at our first class. Sorry, our smallest alcohol. The smallest alcohol we can have is this one with a chemical formula of CH3OH. And if I were to draw this out stereochemically, it would have a carbon in the center, a tetrahedral arrangement, and the three hydrogens and the one hydroxyl group are bonded to it in a tetrahedral geometry. And because I just have the one carbon, I would refer to this molecule as methanol. Alcohols are highly flammable and they can be volatile. Methanol is very volatile, so if you have it in a lab, it's really important to keep it contained with a lid and keep it in a fume hood because methanol you can't really see. Yeah, but the vapors can leave and disperse throughout a room, and if you have a flame or anywhere in the room, that can be quite dangerous. So methanol is our smallest alcohol. The next alcohol is a 2-carbon chain with a hydroxyl group coming off. So chemical formula would be CH3, CH2OH, and when I draw, I'll just draw a structural formula for it, expanded structural formula. You'll see a 2-carbon chain, but one of those carbons will have the hydroxyl group attached to it, and when we name this, we call it ethanol. So this is ethanol. This is the alcohol found in alcoholic beverages. When you look at the alcohol content of a beverage, this is what it's measuring. It's the concentration of ethanol in that bottle of wine or bottle of beer or spirits or liquor. So there you go. There's ethanol. Some antibacterial soaps might have some ethanol in it. Some gasoline will have some ethanol in it. They add it to it. So that's ethanol. It also used to be called grain alcohol. Sometimes it's also called ethyl alcohol. Those are some other common names for it. It can be highly toxic. Doesn't do great things for your liver or your brain cells. And, consumed in consistent drinking of it and lots of high doses of it. So please keep that in mind. And the next class, this is where things change a little bit, is when I have 3 carbons in the chain. So here's a 3-carbon chain propane. And if I add an alcohol to it, sorry, a hydroxyl group to it, I can actually add it in two different places that would change the structure of the molecule. So if I add it to the end like this, it doesn't matter if I add it to this carbon or this carbon, it would still be the same molecule because I could just rotate it 180 degrees and I get the same thing. When I draw a line structural formula with a hydroxyl group, remember that every point in or vertex in the chain represents a carbon. So there is a carbon right here where I'm pointing that's bonded to the OH group, the hydroxyl. So don't miss that one. So this makes it a 3-carbon chain. And the hydroxyl group needs to get the smallest possible number because now the hydroxyl group is our priority when we name it. So when I number the carbons in the chain, I have to number it such that the hydroxyl group gets the lowest possible number. So the hydroxyl group needs to get the lowest possible number. All right, so how do I name this? I numbered it correctly. It's a 3-carbon chain. So the root is going to be propane, but with an alcohol, I drop the E and I just write propan. Then I write a hyphen and I write the number of the carbon that the hydroxyl group is bonded to. So this would be propan 1. Then I write another hyphen and then I write my suffix. And the suffix for all alcohols is going to be -ol. You've seen that with methanol and ethanol. When I have a hydroxyl group bonded to carbon 1 in a 3-carbon chain, it's called propan 1-ol. All right, now I'll show you a slight variation to this. What if we have that hydroxyl group coming off of the 2nd carbon? Well, now I have a completely different chemical because now that hydroxyl group is coming off of a different carbon. And same kind of thing, it's going to have the same root because it's still a 3-carbon chain, but now the hydroxyl group is coming off of the 2nd carbon. So I call it propan 2-ol. Propan 2-ol. All right. The next one I want to show you is what do we do if we have multiple hydroxyl groups coming off of a main chain. So let's do something like this. So what do we do when we have 2 hydroxyl groups coming off? It's still an alcohol. So the first thing I do is I number the main chain. In this case, it doesn't really matter which way I start with. I could start left or I could start on the right, but the way I number things will stay the same regardless of which direction I go in. But you do want to make sure that your alcohols have the lowest possible numbers. So here I get 1, 2, 3, 4. So the hydroxyl groups occur at carbons 2 and 3. So I would start naming this butan. Now here's the difference. When I have multiple hydroxyl groups in an alcohol, that's when I can leave the E on the root. So I would name this butane, then I write a hyphen, and then I write the numbers where the hydroxyl groups occur, the numbers of the carbons on the main chain where the hydroxyl groups occur. So this would be butane 2, and then I have another one at 3. Make sure you write commas between the numbers. Butane hyphen 2, 3 hyphen, and now I write diol. The di indicates that I have 2 hydroxyl groups coming off of the main chain. So butane 2,3 diol. So if you have multiple hydroxyl groups, you need to use that Greek prefix di, tri, tetra in front of the suffix. So this would be butane 2,3 diol. All right, the last one I want to show you is what do we do if we have a hydroxyl group coming off of a benzene ring. In this one, it's kind of hard to intuitively come up with this on your own, but the name for this is actually, I'm just going to tell you, it's phenol. And you kind of look at this and you think, well, why didn't they just call it benzol or something? Well, they didn't. They went with phenol. So If you see a benzene ring with one hydroxyl group coming off of it, that is referred to as phenol. That's just something that you're going to need to memorize. All right, so that's it for naming alcohols for this video. And I'll see you in the next one where we're going to look at alkyl halides.